Hey, Science fam, we are continuing to work on our heating and cooling curve calculations, and we are jumping into number 6 from our worksheet number 1. If you take a look, it's asking for how much energy is needed. So right off the bat, we know energy, we're looking for Q. How much energy is needed to completely boil away 150 grams of water at 18 degrees Celsius to steam at 100 degrees Celsius. So first of all, we're starting with liquid water and we're going to go to steam, which is a gas. We're starting at 18 degrees Celsius, which means we're starting somewhere in this box because we are warming up water, right? So that's something that we know. And then we're headed off to steam. So we're converting from liquid to gas, which means we have to be boiling. So we're also going to be headed in this box as well. So if we know our temperatures really quick, 0 degrees, water starts melting, and 100 degrees, water starts boiling. That might help us out a little bit, but it does look like we're going to be using boxes C and D. So let's start with C. Of course, C right here, we know we're going to be using the equation Q equals C delta T. That means then that Q is going to be equal to, we know there's 150 grams of water. Our specific heat we're going to be using, it's given to us in the water heating curve worksheet. So it's going to be 4.184. And then our change in temperature, this is the part that people goof up a lot about. Now remember, it's at 18 degrees, but in this box C, it can only go up to 100. So that means that the final temperature in box C is going to be 100, and the starting temperature was 18. Okay, now that we know that, 100 minus 18 is going to be 82. So that's going to be 82 times 4.184 times 150. I'm going to throw that in my calculator, 150 times 4.184 times 82, because that's 100 minus 18, and I end up getting about, let's see, 51,463.2 joules. Okay, that's good. That is the energy for box C in order to heat up the water to 100 degrees. But once it gets to 100 degrees, it's going to start boiling. So we know for that part, for part D, it's just our energy equals our heat of vaporization times our mass. So Q is going to be equal to our value of our heat of vaporization, HVAP, times mass. So we can plug that in really quick. Our heat of vaporization is already given to us, so that's super convenient. 2260 joules per gram times the mass. The mass of our water is going to still be 150. So I'm going to multiply those twos together. 2,260 times 150 ends up getting me about 339,000. So 339,000. Sorry, I had to switch up my color and make that correction. Okay, so 339,000 is what it ended up equaling. But that is your energy for D. Remember that this water went from 18 degrees and then boiling, so we have to find the total energy of both, which means we just have to add up both of the energies. So add up 339,000 plus 51,463, and what you end up getting for a total is about 390,463.2 joules. And there you go. You have to first figure out what box or boxes does this problem fall under, and then from there, actually calculate the energy. But you got it. Hope that helped out a little bit, Chem fam. Keep going.